Hey everyone, it's Mr. Anderson here. We're on our second lesson in our third chapter, our third unit in our CPM, Common Core Algebra book. We are going to continue to simplify using properties of exponents, and our focus today is going to be 3.1.2, how can I rewrite it, but specifically highlighting concepts that help us evaluate things with zero and negative exponents. I've gone ahead and prepared a couple of notes here, and I'm going to remind you real quick of some things that we did yesterday, but I'm sorry, it's things we did in our last lesson, but like I said, our main focus today is going to be using zero and negative exponents. And let me entice you with the promise that you already know some things about these things, and we'll once again investigate these things using patterns. But before we do, let's find in our textbooks 3-12 or 3-12, and we're going to one more time reinvestigate a couple of rules from yesterday. I've got 3 problems selected here, and these I think are going to go pretty quick. Let me tell you, we've got x to the 7th power, and that is a base of x multiplied by itself 7 times. Okay, and this actually ends up being a very, very important property for us, and that property is going to be what we refer to as the product property. And then I'm going to be multiplying it by another base of x to the 4th power, and that's x multiplied by itself 4 times. And then here's the idea. You're going to take these x's, right? They all have the exact same base. They all have a base of x, so I can rewrite it as a single x. But now the question is, how many times do I have those x's? And I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. I have x to the 11th. So there's my simplified expression, x to the 11th power. All right, I'm going to model something else. Similar concept, different property. I have x to the 3rd raised to the 3rd, so that'll be x to the 3rd multiplied by itself 3 times, right? 1, 2, 3 times. And again, where is that coming from? That's that 3. Is the exponent telling me to do that? So then I'm going to rewrite this without any exponents. There's the first x to the 3rd. Here's the next x to the 3rd. And then here's the final one. Okay, and at this point, because the exponents are gone, the parentheses are pretty trivial. And what that means is I can kind of just drop them. So let's investigate quickly then, how many x's do I have? And I say how many x's because I've already noticed that these things are the same base. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. And notice what I'm doing. I'm doing a little skip counting there using maybe some multiplication, and maybe you already recognize that, okay? 3, 6, 9, right? There you go. Okay, that's x to the 9th power, and lastly, the last property we're going to do the deep dive on today before we get into the zero and negatives is going to be this quotient rule, or quotient property, and it looks like this. I've got m to the 14th divided by m to the 2nd. Notice this is a division bar, okay? So that's going to be, oh man, 14 m's, okay. Buckle up. 1, 2, 3, 4, 5. Oh, it's not going to let me write any further there. Hang on. I got to start this over. Let's try one more time. Try down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Holy cow, a lot of m's. And now on the bottom I've got m multiplied by itself twice, or m squared, right? So 14 up top, 2 on the bottom. You can see, of course, why we write these things using that condensed notation. And now it is going to be something we're going to need again later, recognizing that if we multiply and divide by the same thing, those are inverse operations. They cancel. And if they do, what remains? You can spend a little time maybe speeding ahead of me, counting those up. How many m's do I have? Maybe you already arrived at that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Holy cow, there's 12 of them, right? Could you have beat me to that, right? There are 1, 2, 3 pretty necessary properties for us, and those 3 pretty necessary properties are going to be referred to, as I said, the product property, the power to power property, and then of course our quotient property. And maybe, just maybe, you can start to expand on these things. We're into the next problem. This is 3-13. We're going to define these three rules. These would be excellent for your notes to throw in there. We've got x to the 25th times x to the 40th. This is what's going to be referred to as that product property. And we can rewrite this. I could write 25x's. I could write 40x's, and then I could add them all up. But in general, this becomes x to the 25th plus 40. So this would become x to the, I'm trying to write this, 65th power. And our generalization is that when we go ahead and do this, we've got x to the m times x to the n power. And here's how you're going to see it written in textbooks. This becomes x to the m plus n. Pause the video for a second. Write that one down. Okay? But then I've got another piece here. Why the heck is this true? Well, that's because when you're multiplying like bases, you're able to add those exponents. Okay? Multiplying by another, in the case here, 40x's means I've just added another 40x's to the multiplication process. So we'll just add another 40 to that exponent. All right, the next property is going to be what's called our quotient property. And that's how you spell quotient, Q-U-O-T-I-E-N-T. And we've got x to the 36th power over x to the 13th power. Ladies and gents, a lot of people just want to divide. Oh, x to the third. No, you could write out 36x's. You could write out 13x's on the bottom. But in general, our general rule becomes x to the 36 minus 13. So this would work out to be x to the 23rd power. And folks, the general rule says, hey, if you've got two like bases with different exponents, you are dividing them, you are allowed then to subtract those exponents. And that's for the reason exactly what we saw here. All right? I can deduct those ones from the bottom because I'm canceling also, from the top, right? That's why that one's true. So we're dividing like bases, we subtract the exponents. Last one of these is going to be the power to a power property. Power to a power. And these, of course, are going to be called different things depending on where you look. You can, how to put it, you can vary Mr. Anderson's language, but it's, no big deal. People will know what you're talking about. I've got x to the 5th raised to the 12th. Now, this is big. That's x to the 5th 12 times. It's going to be a lot more than x to the 17th. So think of it. It's like writing x to the 5th in that set of parentheses, x to the 5th, x to the 5th, x to the 5th 12 times, and then expanding all those x to the 5ths. So there's a lot of nesting that would be going on here. And because of that, whenever you have a power to a power, as we do here, we've got x to the 5th raised to the 12th, you are going to multiply those exponents. And in doing so here, x to the 5th times 12 power, this becomes x to the 60th power. Like I said, a lot bigger. All right? And in general, our power to a power rule for that same reason becomes x to the m to the n, x to the m times n power. And ladies and gentlemen, that's because nested parentheses end up nesting n times, or in the previous example, 12 times. And you'd have to rewrite them that often. Okay, let's keep on keeping on, because there's two new things I'm going to throw at you today. And we're going to do 3-14, and it's really important. It says, hey, describe everything you know about x to the m over x to the m. I know that gets a little bit blurry, but if you want to see that, we did something like this in our last video lesson. And in general, you've got something over itself. Now imagine it's not a base with an exponent. Imagine for a second it's something like 2 divided by 2, right? It's 2 shared two ways. Let me slide that over slightly. 2 shared two ways. You have $2 split between two people. Well, we've known this for a long time. Something over itself is 1. Okay? The exact same thing is true here. if you've got x to the m items, this is a great counting problem. X to the m items split x to the m ways. It's no different than that 2 over 2. It is 1. It's a simple 1. Now, what we're going to go ahead and do is we're going to draw on this. We're going to take that rule because now we've got a new way to write this using that quotient property, and we can take this and we can write it like this. Okay? You, of course, know what m minus m is, or something minus itself. Well, golly gee, it's an equation. Shouldn't these be the exact same thing? Interesting. Let's keep pushing that idea. All right? Let's keep pushing that idea. Something that would be good for your notes. All right? We're going to keep going here, ladies and gents. We're going to talk about what happens here when expanding and using some of these properties. And what I want you to notice in 3 dash, what am I on here? 3-14? Oh, I'm sorry, 15. What I want you to notice in 3-15, that exponent on the bottom is bigger than the one on the top. And if I expand this, that's x to the fourth, so x, 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 x. And then on the top, I'm sorry, on the bottom, x, 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 because that's x to the fifth. Now, check this out, because I'll go ahead and strike these. Those cancel, these cancel, these cancel, and these cancel. Well, what do I got? I've got an x left, but where the heck is it? It's on the bottom. All right, well, what's left on the top? A lot of people want to write 0. It's actually not 0, because even though I struck all the factors of x, there's still a factor of 1 there. So this is going to be 1 over x. Now, initially, that doesn't look that impressive. But if I remind you, this is 1 over x to the first power. Well, now we're going somewhere. Okay, now check out this alternate representation, because one more time, I'm going to take this, and I'm going to work that quotient rule. Right? We know what the answer should look like. But look, that quotient rule says I can take and rewrite it like that. Well, what's 4 minus 5? And folks, here is our rule for negative exponents. Okay? Anytime you have a negative exponent, you're allowed to rewrite it in the denominator of a fraction or of a column or whatever you want to call that, and you can rewrite that with a positive exponent. They're not. It'd be inappropriate if I didn't change the sign on that exponent, but ladies and gents, the same thing is going to work here with b. Okay? Check this out. I've got b here, and I'm going to just expand this. X squared over x to the fourth. Well, that's x times x divided by x times x times x times x. Again, initially not looking that impressive, but let's strike what we can. Okay, those things are gone, and then I can rewrite this using that same strategy. Okay, 1 over x times x. All right, well, that's the same thing as 1 over x times x. Hey, that's just x squared. All right, okay. Let's try this. Well, that's x to the quotient rule says I can do this. And 2 minus 4 is, oh my goodness, check that out. Okay? That same exponent appears. The only thing we had to do was flip that side. Ladies and gents, that's your negative exponent rule. The same thing is going to hold true for C there. There is a little review preview here at the end of this lesson. It is problems number 19 to 22. Let's go ahead and tackle these, give everything a shot, make sure you're checking your answers. If you have any questions, please reach out to your math teachers. Ladies and gents, thanks for watching. Have a great day.